What's up, everybody? Welcome to Building Web3 Anything, episode 6. This is all about Friendtech, and you can consider this a part 2 for episode 5, where we started building a Friendtech app from scratch. In this particular episode, we're not going to go as deep into the actual building mechanics because there's a lot of ground to cover and a lot of cool things and features from Friendtech that are worth talking about, and in particular talking about how you can build it in 100% no code. So we built Friendtech from scratch in 24 hours. And part of this is to explore, well, firstly, why did we choose to clone Friendtech? And secondly, what were the specific key features, the killer features that when all put together made Friendtech what it was, which is, by all accounts, a huge success in Web3. So, firstly, why clone Friendtech? Well, we can take a quick look at their stats, for instance. And they've accumulated over 13,000 ETH, which is, something like $20 million worth of ETH in terms of transaction fees. They have over 800,000 users, let's call it, on average. And that number's going up. So definitely this app has done something right? And I think from an app building perspective, the reason why for me it was really an interesting challenge to try to clone was for a number of things. And that's a perfect segue into the features, right? If you think about Friendtech, what makes Friendtech? Well, it's a couple things. One, there's smart contracts underlying it. We'll get into that, but it's called a bonding curve, but effectively it's the thing that allows you to buy and sell keys for particular users. Second, the app is entirely mobile friendly. Even more so when they first launched, it was mobile first, rather mobile only. And if you're actually being, precise about it, because they actually diverted any attempts to log in from a desktop and gave you a pop-up and said, if you want to use this app, you got to go to your mobile app or mobile browser in order to do it. And so a pretty interesting decision, right? Like they very well could have delayed the app, let's say, and tried to get more desktop functionality in first. But I think it was a pretty bold decision. I think it was ultimately the right decision. If you look at some of the stats, just anecdotally, depending on the type of app, you may have upwards of 90% of your users coming into the app via the mobile browser first. And if there's a really smooth onboarding process for them to go from the browser directly into an installable app that looks and feels like a native app, and that's the next thing that was key for Friendtech, was their PWA or progressive web app strategy, right? They leveraged the browser and immediately gave instructions for the user to install that app as a PWA. And for those who aren't familiar, we'll walk through that. But a PWA is effectively a web app that has some configurations that these days the most popular OSs, Android, iPhone, even Windows, actually understand, and they'll understand. Oh, you can install this app, and it'll show up as an icon on your desktop or your home screen. You click it, it'll look and feel like an app. It won't have the search bar, and more critically, it'll have things like notifications, which Friendtech uses a lot, or rather uses really well. So that's another key feature. Thirdly, their onboarding. So I think, again, a pretty bold decision here where they eschewed or ignored a lot of the typical onboarding, which is, hey, input your name, input your Twitter, input your profile picture, etc. They just had one step, which is just connect your Twitter or your X account, and we'll do the rest. And I think just going through that process myself, it was a bit of a revelation for me, because I think it just makes a lot of sense. One, I mean, it's a social-fi app. And a lot of the users they're targeting already have a pretty big Twitter or X presence. And so that made a lot of sense. And then secondly, in terms of onboarding and populating your user account, what easier way to do it than just to pull the profile picture, username, handle of their existing account and just do that all in one step. It saves a ton of inputs and a ton of time for the user. So again, something I think they did really right. Fourthly, their whole method of account abstraction. So focusing on a social media, or they actually use a phone number as a login too. Again, there's that mobile focus. I think that not only is the right approach for them, I think that's the right approach for Web3. Because these days, even some of the OG Web3 apps, they're still too Web3 focused, in my opinion. They are looking to users to log in with MetaMask and Wallet Connect. And frankly, that already just, kind of turns away a lot of non-Web3 users, a lot of mainstream users, because the vast majority of people still are not super comfortable or even familiar with what MetaMask is, how it works, and things like that. And they may not be willing to invest the time to learn it. So why not, again, meet users where they are, right? Have them log in with the methods that they're used to, like Gmail, Facebook, and email or phone numbers, etc., and which is exactly what Friendtech did. And again, I think it's a big reason for their success and a reason why they have had, this may be worth looking at the stats, but I would say they've probably had a lot of success also onboarding brand new users into Web3, which is critical for all of us working in the space. Finally, the integrated buying and selling of keys. So this may not be something particularly innovative for Friendtech per se. It's kind of a given that they would need this. But if you're building this app from scratch, then this is absolutely something that is both critical and not the easiest thing to do if you're doing it without a proper framework or tools or plugins, right? The good news here is we do offer these plugins. There are tools available to be able to have your app in nocode, in Bubble specifically, be able to talk to and read and write to smart contracts on chain completely in nocode. And again, that's a critical piece, obviously, to Friendtech. It wouldn't be the app that it is without being able to buy and sell users' keys. And if you're going to clone it, you absolutely need that. The last thing that we'll touch on here is that what's the goal here, right? The goal is not necessarily to clone Friendtech Part 2 and launch it, right? The goal is, one, to understand all things that Friendtech got really right and to see how we can accelerate and build upon that framework that they've set up and really made successful or proven that can be a key ingredient to success, among other things, and then build from there, right? So not only can you take all of these key features that they've established, build them yourself in no code. And as we've talked about, we did that in 24 hours or less. But you can then extend those features. So if you might imagine, what if you took something like a Friendtech and you integrated NFT minting into it, right? So Friendtech, we'll kind of go to some of the screens here. So Friendtech, for those of you who haven't necessarily seen it, at the end of the day, it's the combination of a privacy token, a key as they call it, and a chat room. And so in the chat room, right, you're only able to see that chat room, get access to it if you purchase that particular user's key and effectively subscribe to that user's room, right? So why not, in that chat experience, allow for the room owner to also mint an NFT for their key holders? I mean, I think that would be super cool, especially, and we'll kind of walk through how I think that might work in the app that we built. But again, this is just one example. What else could we do, right? So minting the NFT. Also, the one thing I think Friendtech could improve on is in terms of their payment infrastructure, right? They are still very Web3 focused in terms of how they are asking the user to sign up and get a balance and purchase keys. It's all still very crypto oriented. I think there could be a huge benefit there to even making that as user friendly as possible, i.e., making that purchasable by credit card. That'd be a huge thing. Somewhat related, being able to add a balance to their account by a fiat on ramp, right? So purchasing crypto with the credit card again to get an initial balance. And there's other things too, like even using something like a gasless mechanism, right, where maybe their initial transactions on chain just to get set up and things like that are entirely gasless. So there's a couple of things we can do on that side to make the experience even more Web 2 like, or as I like to call it, low key Web 3, where the Web 3 is there, but it's abstracted away to the point where it's almost invisible, right? I think that approach is the key for Web 3 to get to the next level. So let's just step through real quick in terms of some of these screens and then draw them back to the prior page, right? So working from left to right, add to home screen. They've since evolved the app so it's now also desktop usable, which is cool. It did take them, I want to say maybe like 8 weeks to get there, 6 to 8 weeks. But initially when you logged in from a desktop app, it would just pop up this thing and say, nope, sorry, you got to go to your mobile browser. And if you think about that, the fact that they still had the success they did, again, speaks to all the other little decisions they made, and they ultimately made the right one. They're like, look, we're just going to launch this thing straight up, go 100% mobile to start. If we have the benefit of being able to do it, we'll add desktop later. But we know where our users are. They're going to be on mobile. They everybody who uses social apps, they're using it through their mobile device. So that's where we're going to go. So I think they made 100% right decision in that case. In terms of the login experience, again, account abstraction, as some people in our space would refer to it now. But for a normal user, they just call it logging in. It's just like any other website they want to get into. Oh, okay, I can use my, and in this case, it's like a mobile app experience. Oh, I use my phone, cool. I'll just log in with my phone number. That's kind of like WhatsApp, or my Google or my Apple. Cool, that all makes sense. So again, none of this MetaMask login things like that. The interesting thing is they have this whole experience and this onboarding workflow to initially get a balance in your account, right? So because they're using account abstraction, every single user that logs in gets a brand new wallet generated for them. And so it's a zero balance. So it's a brand new wallet. It's not going to have any currency in it. So they had to think about a way to make the initial on-ramping or the payment into that balance just easier, as easy as possible. And so what they did was they actually have a couple of options. One is, if you're more familiar, you just, oh, okay, that's my address. I'll just send some, in this case, base ETH to that address. But they also had a separate page. We're not going to jump into that particularly, but they had a separate page they set up, which is just simply a deposit page. And again, I think they did some really cool things there where they give you like a four number PIN. You log in with your PIN. It takes you directly to the user who's going to receive it. And basically that particular page are able to log in with MetaMask, Wallet Connect, all the things, right? But clearly there was a specific decision to separate that login workflow from the rest of the app. They didn't want to muddy the waters, right? So they isolated any MetaMask, like kind of typical Web3 interactions into this like one page that they set aside, which is like, okay, if you're going to use MetaMask, use it on this deposit page. And again, I think that speaks to their product decisions, where they're making very discrete and specific decisions to focus exactly or specifically on what the user, where the user is and where they're coming from, which again, I think was super smart. So thirdly, right, the chat experience. If we're going to build this app from scratch, we need a chat experience. So we're going to actually step through a little bit of the mechanics, go behind the scenes in terms of my app and how I set it up. But in not too much time, you can actually more or less replicate 100% of their chat experience. I think what makes their chat experience stand out is just it's really clean. There's throughout their entire app, if you don't even get that from just looking at these screens, I think there's not a lot of fluff, right? So moving on to the next key feature, and if you're starting to get the idea, the things that Friendtech did, none of them are particularly new per se, but I think the combination of all of these little things together and each of these right decisions that they made, it adds up. So the sum is greater than the parts, if you will. So another example of this, right, is the fact that once you log in with your wallet or with your social media account, you're able to get a non-custodial wallet. And what this means is this wallet is yours. So you have access to the private key. So for example, here in the screen, they have a button, export wallet, and it's absolutely critical, right? So for Web3, in terms of the Web3 philosophy, the whole concept is you should be able to own your assets online. And to start with this easier onboarding is a key first step. But ultimately, as people ramp up and understand, oh, wait a minute, like I actually do own these keys. It's not just stored in somebody's database, like like a Facebook or something like that. And once they realize that, it becomes absolutely critical for them to have this little button, export wallet, which means they can take their wallet address, they can export it to whatever other wallet application they want, whether that's MetaMask or Trust Wallet, Rainbow Wallet, etc. And that's just one of the core principles of Web3 and super important. Finally, I think just the fun, the fun aspect of it. So yeah, there's some controversy about the purpose of Friendtech and is it speculation all over again? There's definitely some of that. But I think, again, what they got right is you just get drawn in and see a lot of this activity, right? So you log in. When I logged in for the first time or connected for the first time, immediately 3 or 4 random people bought my keys. I don't know why, but basically I think there's just people out there looking for new users and just hoping that maybe they kind of strike gold or something like that. But the experience as someone logging in is kind of cool. Like you log in, oh wait a minute, somebody already bought my keys. That's kind of cool. And so I think they struck that. And at the end of the day, they're all pretty simple features, right? It's keys, transactions, and chat. And so as we now kind of step into the actual app itself, we'll walk through how we actually can use tools to tackle each of these specific functions and features. So firstly, the smart contract is the heart of the entire app. So if we take a look at, or rather, if you just do a search for Friendtech contract, you can find it pretty easily. And again, kudos to Friendtech, right? They didn't have to verify this contract. They did. So, right. So they didn't have to necessarily verify their contract, but they did. So it's out there for anybody to take a look at it. Like I said, you can just do Friendtech contract, do a search for that. It'll show up on the base Chain Explorer because they did deploy this on Coinbase's new protocol. And the big reason for that was it's a very closely related L2 to mainnet ETH, but obviously the transaction fees and the gas fees are going to be a lot lower than mainnet. So if you take a look at the contract, and we're not going to step through this in gory detail per se, but the key here is a couple things. The makeup of this contract, again, I'll say it, they just have a really laser focused approach. There's not a lot of fluff in their app, and there's not a lot of fluff in their contract. This single file is their entire contract that they've used to generate $20 million in fees. So if there's anything that speaks to the power of Ethereum-based protocols, then this is one pretty good example. And if you look at the contract itself, this entire thing is 200 lines of code. I mean, if you take the spaces out, it's probably 180 or something. So it's just mind-boggling, right? And on top of that, the two pieces that they've included here are two of which are boilerplate. So they have some basic setup, like infrastructural stuff from OpenZeppelin, which is a completely open source library. They have a basic import of the concept of ownership, ownable, which again is a very standard OpenZeppelin library. It's included in pretty much every, like, let's say every NFT and every ERC20. There's the ownable library. So really, really, if you're looking at their custom code, it's this section here, Friendtech shares v1, and man, yeah, it's just really concise. I think there's something to be said about just looking at how they set this up, and the function calls and even the naming conventions are just super clear. The calculations, their arithmetic thing, I had to actually look this up, but basically this is like going back to, I don't know, high school or college, like algebra at this point. And basically there's the function which gets you the geometric progression, right? So every time somebody purchases something, the next price is based on the square of the sum of the supply, effectively. And so they've figured that out and put that in. And so you can take this contract, and as I did, I deployed it, and what I used was Remix, the Ethereum IDE, literally took that contract, copy pasted it into another Sol file, and put it into Remix, connected my, MetaMask or Wallet Connect or whatever, pointed it at Polygon Mumbai, compiled it. One thing you do have to take note of is when you compile it, you do want to compile it using the version of Solidity 0.8.2 that they used. But once it's compiled, you can deploy it, and you might get a confirmation pop up in the MetaMask that you use to connect, and it's on chain. I mean, if I look at my contract in my app, we'll go to Polygon, Mumbai.polygon scan, and actually there it is. And not surprisingly, if you go to look at the code, if I can click the code, I'll move my buttons here, there you'll see it, right? And transactionally, this thing is fully functioning. It's buying, selling keys. And so I think that not only speaks to the openness that Friendtech is taking, their stance on things. In fact, they also had their API open. They got some press on that. But they're, again, kudos to them, right? So one thing I think is worth mentioning, even though in their contract, there's no, strictly speaking, a license per se. So typically when you create a new smart contract, they recommend that you put some license on it, like open source, MIT license, etc. There isn't anything like that on here. So I wouldn't recommend, I'm not a lawyer, but I wouldn't recommend just taking this thing straight and then just like trying to launch your brand new startup with it or something like that. I think what you could do is use this for inspiration, or take it, potentially build on it, modify it, things like that. But just this is again for demonstration purposes, and it's but it does go to show how easy it is to take and to build off of what someone previously has built and innovated around. So coming back to our recipe here, let's say we have the smart contract, so we have that deployed, and we could deploy that in anything really. Mumbai, could be Go Early, whatever you choose, could be an L2. So the mobile browser side of things. So this is something I spent a fair amount of time looking into because it just intrigued me. For me, maybe I've been living under a rock or something like that, but I didn't realize. I mean, for me, PWA typically meant like wrapping your app and trying to deploy it into the app store, so Google Play or the Apple App Store. And so when I first checked out the Friendtech app, and it was just like, oh, just add this to your home screen. Again, I think this is not something new. I just wasn't kind of fully up to speed on it, to be honest. But that was like a huge aha for me. The fact that you can do that, and this brought me down a rabbit hole of just looking further into PWAs and this install approach, which is installing straight from browser. And the really cool thing here is that you can do this as well, completely in no code. So I have another app here, which I actually installed already onto my desktop, if I can see. Yeah, my One Gallery app. So when I loaded this up, and actually I can see if I can do this again. But when I loaded this up, there's some configuration files in the background that so here you see, right? And pop-ups that give you just clear instructions. Hey, you want to install this? Install it straight to your desktop or your home screen. Now, these features, these pop-ups and things like that, are actually part of the Progressier service, and so you can do these. I've experimented with doing these as more of a homebrew, and there's instructions online. If you search Bubble PWA, there's a couple people who have gone down that rabbit hole. There's basically a couple files you need to install in the root folder of your app. There are some scripts you actually need to draft, you need to write, or you need to use some tool to generate them. So there's definitely steps involved to do it. Progressier basically does those steps and then some. It gives you some additional customization, like on the UX side, having a pop-up for installing, and a bunch of other things like the home screen, the button that shows up, all that. And they do a pretty good job, right? I think actually they do a really good job. And the onboarding for Progressier, when you log in, it'll ask you which app you're using, which no-code app. So whether that's Bubble or Webflow or Shopify, and they give you specific instructions tailored to that particular platform that you're using, which again, I think is a nice touch. So I'm usually I approach any paid solution with a grain of salt, but I think in this case, I would actually recommend, especially if you're pressed for time and you don't necessarily need to or want to invest the time to go down the specific rabbit hole of PWAs. This is a really good solution. So and with that, you cover off, and again, a really big piece of what makes Friendtech, which is the installable PWA strategy. Now, if we get into Twitter or X authentication and onboarding, now we start to get back into the realm of Bubble. And if we take a look at that, we'll actually look specifically at some of the plugins that we've installed here. The main one here is an official Bubble plugin for Twitter. You install that, you input your consumer keys, and if you need a run through of how to do that, you can just go straight to episode 5, and that's part of the setup that we did in that particular episode. But basically, at the end of the day, once you're able to do that, and then you also need to make some configurations on the Twitter developer side, the dashboard, to whitelist your domain. But once you've done that, you have access to a pretty simple action, which is this one: sign up, log in with Twitter. That's it. You do that, and then after, you're able to get access within the user account to all of the Twitter metadata for that user, right? So for instance, if I go to my login workflow here, I have my first login screen, which is similar to Friendtech, just a straight up login button. That logs me into Web3 Auth, which we'll actually take a look at in a moment. Once I log into Web3 Auth, now I'm connected. I have a wallet generated. So Web3 Auth, and we're going to be, a couple of these are all dovetailing, right? So the Twitter and the Web3 Auth are back to back. So what Web3 Auth does is the account abstraction, the non-custodial wallet generation. What the Twitter plugin does is, yes, it logs into Twitter, but we're not actually going to use that login as the primary, like credentials for our users. What it basically is just, again, a really quick way to authenticate that user, make sure that they're a real person, not a bot or something like that, but also then to pull in one step, all of the just profile stuff, again, pictures, name, handle, things like that, even their follower count, you can pull that. And so we use Twitter for that purpose. And then at the end of the day, what we actually will want going forward is for the Web3 Auth plugin to drive that login process, right? So we'll step through a little bit of how we do that. But in terms of the Twitter process, right? We have this authenticate button. And once they hit authenticate, it'll log them in with Twitter. And let's say this is the first time they're logging in. We will assign a temporary password. So we'll maybe go a little bit into the weeds on this one, because I think onboarding is an area that people sometimes get hung up on. If you're using Web3 Auth to log someone in, just remember that Web3 Auth doesn't necessarily log them into Bubble. It connects them to a wallet, but then you still need additional workflows to log that user in, right? So here we're going to go through that process. And the way we do that is a couple things. So we want to use this action, assign a temporary password to the user. We want to save that temporary password. So here we see user temp password, result of step 5. That's step 5. We also want to have a parameter in the user for the user wallet. And we want to save the Web3 Auth wallet into that parameter. One best practice here, I like to use lowercase for all of my wallet. Every time I try to save a wallet, whether that's for a user, for a smart contract, for an NFT, anything, collection, I like to use lowercase, because more often than not, there's often things that are case sensitive. So if you're doing a condition and you're pulling in from an API, a wallet address or something like that, they're using upper and lowercase, but you're using lowercase, and you're trying to match them for a if this then that type of condition, it's going to fail. You're going to wonder why it's failing, and then you're going to realize, oh, it's because this is lowercase, that's uppercase. So I think here, yeah, there's ways you can do this in the actual condition itself. But generally what that would require is an advanced condition where you're modifying both sides of the equation. So like, hey, I have this value, I want to make it lowercase. I have this value, I want to make it lowercase. I have this other value, I also want to make it lowercase. I want to make them equal to each other. The long and short of that is that actually requires more computation from Bubble to do. So it's a little more computationally efficient to just have something where it's pulling the parameter and then doing a simple equivalency just on an existing parameter, rather than having to like modify both. So a little into nerding out on the Bubble side, but then here's the cool stuff, right? So once they're logged in with Twitter, there's an additional parameter that Bubble populates. I did not create this Twitter sub parameter. This comes along with the Twitter Bubble. It's built in, but along with that, you get a bunch of stuff. You get their name, handle, follower account, profile picture, Twitter ID, description, banner. So like I said, rather than creating a whole form for the user to input these and then also just like not really have consistency, this solves a bunch of things in one shot, right? And again, I think it's super smart for Friendtech to take that approach. I may actually just adopt this for my future apps, right? Because I mean, all told, when you're creating a form with all those parameters and inputs and things like that, it's pretty time consuming, right? I mean, not only for you to build, but also for the user to put in, like, depending how many you set up, like 3 to 6 different inputs, upload a picture, all that stuff, right? So you're easily saving the user like 5, maybe even 10 minutes on that front. And this is a critical action, critical step. Update the user's credentials. Here we use, because we updated the user's password right before, we can use that temporary password and then straight away update their email, right? Because they previously they would have logged in. So the first time they log in with Twitter, I think it may use their Twitter email, which may or may not be the same email they've used to log in with Web3 Auth. And this just makes sure that we're doing apples to apples. So this is setting going forward their email to the Web3 Auth email. So again, we don't want them to have to authenticate in Twitter every time they log in, right? So now going forward, they're no longer going to be a, this is the little toggle here, or this yes, no parameter, user first login. Ideally, after these steps, we turn that to no, and then next time they log in, it'll go down this path instead, right? User first login is no. And there, again, we'll kind of skip over the authentication step and go straight to, let's say, either a balance page where they're going to get some cryptocurrency, or go directly to the homepage, right? So this is a critical step right here, just to set the user's email. And again, it's a specific function, call, or action in Bubble. Update the user's credentials. You can also use it to change their password, which we are going to use in a moment. So the typical way you want people to sign in with their wallet from an app perspective, it's kind of a security thing. You want to ask them to sign a message with their wallet. And here I have a default signing message. I've stored this in an option set, actually, just so I don't have to, again, two basic principles of coding, or no coding for that matter. One is build once, use many times. So if you know you're going to be using even a variable, a value, a bunch of times, you don't want to have to punch it in every time you're using it, right? So what I've done is I've often either used option sets in Bubble, or I've used a custom data type to just store default values. And as you can see here in this example, I have a set of default values, and here's my app signing message, right? So now I'm just going to refer to this. Every time I'm looking for an app signing message, I'm not going to write it from scratch. Particularly for signing messages, that's super important, because if there was literally one character different, if I forgot to put the period, if I put an extra space, the output of that signing message is going to be completely different, right? And if you're using that output as a password, like, guess what? That user's not going to be able to log in. So super important to be really consistent about that particular value, but generally important to be consistent with values just because, right? Like, it'll save you time and headache down the road. So in this particular case, we are going to sign this message. This is a good best practice to have if you're building a Web3 app, because it's just an additional step to make sure that user is who they say they are, right? In the Web3 context, more or less, you are your wallet, let's say. We can get into like little philosophical discussions around account abstraction now and things like that. But more or less, when you connect with a wallet, you're saying, I am the owner of this wallet. I'm in control of it. And I have the private key to it, right? And when you sign the message with that private key, you're proving that fact on chain, right? And so here we have the response back from the Web3 Auth plugin. The signature has gone through, it comes back. Now, if this is the first time they're logging in, we are going to use that password, and we are going to check the box here, change password, use the Web3 Auth signature, and establish that as their new password. So now you can kind of see the steps in the logic, right? So first, brand new user, log in with Web3 Auth, cool. We have now a wallet address for them generated. We have their email, right? And the other thing, the reason why we have their email is we have limited their login options. There's a lot of login options for Web3 Auth, but we've specifically turned off their Web3 wallets. And there's a bunch more options here, but we've limited these down to, let's say, 5 or 6 of the most popular social media or most common social media apps. So we know coming in that they're going to have an email, right? And so they log in, we have an email and a wallet. They then authenticate with Twitter. We pull down their profile stuff. We log them in with Twitter. So now they are actually logged into Bubble, but we don't want to have to authenticate with Twitter every time that they log in. So we're going to kind of pass the baton, right? And this whole process is that process of passing the baton. So, like I said here, what are we doing? What do we mean when we say passing the baton? Well, we want to make that user's email now the Web3 auth email instead of whatever came back from Twitter. We actually don't want to concern ourselves with that. It's too much. And then secondly, we want to now set the password to this signature, right? The signature that comes back from Web3 auth. And those are those two steps we just walked through. This last one being the new password being set up. And now we can log the user in. And you'll see this is the key. This is where everything comes together. We use the Web3 auth email and the Web3 auth signature. User's good to go. We can then, for the first time, turn off their parameter, their first login parameter. They're good. They've now gone through all the steps. Congrats. And then we can send them off on their merry way. If the user's balance is 0 or empty, we'll send them to a subsequent page, which is to get a refill. And then finally, if their user balance is greater than 0, like good to go. All right, just to finish this out, we have one more screen here that we've incorporated, which I've tried to make a little more user-friendly. It is specific to the demo, so I'm not going to focus on it too much. But basically, for the demo to get started, someone's still going to need currency. They need a balance. So what I've done is I've created a little bit of a three-step wizard for them to basically just request that Testmatic from one of the best faucets I'm aware of, which is MumbaiFaucet.com. It's super, super reliable. It's pretty much always up, and you can only use it once every 24 hours, but it definitely gives you enough to do a bunch of transactions, especially on Polygon or Mumbai. And so this is a key step here. It's a little bit different from how Friendtech approaches it because, again, they're focusing on having deposits from an outside wallet. So they have that deposit page that we talked about earlier. But for the purpose of the demo, I think this is I just want to get people up and running and into the app as soon as possible, or as quickly as possible. So I thought this was a good approach. In terms of a real production app, I actually think whether it is the deposit page that Friendtech used, that's one. I think that's still an option you should have. But I think a second option would be really great to have too, which is fiat on-ramp, right? And it does make me wonder a little bit why Friendtech didn't include that as well. Maybe, again, just looking at how they've designed other things, maybe that's because they wanted to keep things really lean and just focus on what they're, the matter at hand, which is chat, transactions, and keys, right? And so, I could kind of see why, but ultimately, if you're going to use a similar framework and a lot of these key ingredients for something else, I do think starting to incorporate credit card on-ramps, credit card purchase would be really great additions. So coming back to the list here, we are looking at integrating buying and selling of keys. So before we do that, I'm going to do actually step into the app here and take a look, right? So what we might try to do, and we'll see if this works out. We'll load this page up with a new user and see how that process goes. All right, so we're gonna give this a shot. We have a new user looking to log in for the first time. They click login. They have immediately this Web3 auth login here, which is, like we said, UX wise, it's a little different from the pop-up that Friendtech has, but functionally, it is the same, if not more, because we actually have more options here to log in terms of social media. They only had Google and Apple. We have Facebook, Discord, and again, there's a whole laundry list of other ones we can use. We are using email as a login here. We do have the option to make that phone or phone number as well. So again, of all the services that are focused on wallet connection and wallet generation, I think by far Web3 Auth is the one that's done the best job so far. I really like how they've approached it and the options and parameters they have. So we're going to log in with this other Gmail account, which should take us to the authentication step. And I'm not sure if I'm actually still logged into Twitter. I might be. Nope, it's not. So let's log in here. So we've logged in to X, and there we go. We've pulled in, this is from Twitter. We've pulled in the user's profile image, their handle, just for fun, their follower account. And now we have this little wizard here where we click to copy our wallet address. We punch that in to the faucet. I think I have a balance already for this account, so I'm just going to double check that. Yes, I do. But otherwise, we could have punched this in, hit Semi-Matic, and again, as long as you hadn't used this 24 hours prior, it'll send you 0.2, which is like plenty for doing transactions. And then we check our balance. That is actually happening on chain as well. So I think that's worth coming back and taking a quick look at. So let's come back to the app and take a look at the index page and this button in particular, right? So this is the one, your balance. And here it is, right? We are reading the smart contract directly. So this is one of the key things about Friendtech. For one, it is an on-chain, it's a Web3 application. But if you're going to recreate it or feature some of what they've built in your own app, this is something you need to start getting familiar with, which is being able to read and write to smart contracts on chain. So here we have built in a no-code method of reading and writing to a smart contract. What does that mean exactly, to read and write to a smart contract? Well, let's take a look at the one that we've deployed to Polygon Mumbai. And for every chain explorer these days, what you should be able to see is the contract. And if they verify the contract, you should be able to click into it and see one of three things: the code, which we looked at earlier, and then these two options, read and write contract. And these are actually the listed function calls for this contract. So for instance, what we're looking to get here is the balance of shares of this user for their own wallet. So meaning the way Friendtech is set up, their contract, if you look at it, you effectively need to like initialize your room by first purchasing your own key. That key is free. So the first one has zero price, right? But it does require some gas fees to actually execute the transaction on chain, which is why they require you to have a balance. You need to pay for the gas. Now, what we want to check here when the user's logging in is, do they have a balance for their own key? Do they own their own key? And if yes, we want to just skip ahead because they're done with that step. If no, we actually want to do that in advance. So this is also a little bit different from Friendtech in that they actually have a couple of like wizard steps where they explain to you, hey, you're logging in for the first time. First thing you need to do is to buy your own key. You got to click a button and then you purchase your own key and things like that. You can go that route too. I think just for demo purposes, I wanted to like basically again abstract that away a little bit and keep that in the background. So here's that actual function called shares balance. And the way we look at it is we go again to the contract on the Chain Explorer, look at read contract, and there it is, shares balance. And this does take a little bit of trial and error to figure out which address is which. Conceivably, you can imagine the two inputs here is one, who's requesting, or rather, whose balance are we checking? And then the second input is for whose room are we checking that amount, right? Like, so user A, how many keys does user A have of user B, right? So A and B would be two wallet addresses. For this particular step that we're doing, which is check the ownership for that user's own room, it's a little easier. We basically just have the wallet address, the same wallet address, the user's wallet for both, and that's pretty straightforward. But to set this up, one thing we do need to input, and you'll see a lot of stuff here, but don't worry, it's not that complicated. We need to copy and paste in the ABI which I believe stands for Application Binary Interface. What it effectively is, it's the instruction manual for that smart contract. It is basically a list of all the function calls, what type of function calls they are, what they expect as inputs, what they'll give as outputs. So again, it's like the manual, right? And to get that, again, pretty easy. Go to code. Typically, any chain explorer, you go down, scroll down to the bottom of the code page, and there it is. Contract ABI. Hit the button, copy, paste, boom, you're done, right? So another thing we could do here actually is, now that I'm actually looking at this and I'm thinking about it, we could put this in the default settings too, right? So we could copy this whole thing. We could go to option sets, and where I have app market contract, I could just as easily add a new parameter, which is app market ABI. And actually, that's, now that I think about it, that's probably the right thing to do. But in any case, for now, we have the function call already set up, and let's take a look at how this then flows, right? So we are calling a function call, a read function call. The response will be contract read, right? And then depending on the actual results, the balance that we see, we may want to do two different things. So if the balance is 0, we'll want to call another, this time we'll call a write function, which is to buy shares. If the function call is greater than 0, we're actually going to trigger our internal workflow, which is to start to record these values into our app database. So, and we'll walk through some of those key objects. But let's go back and take a look at the write function. And again, how do we know which function we're supposed to be targeting? Well, again, credit to Friendtech for just having a pretty clear naming convention for all of their functions, which, trust me, is not always the case. So in this particular case, buy shares, there it is. And there's something that is worth talking about here and drawing a little attention to. So it looks like there are 3 parameters here based on how the Chain Explorer is laying this out, but actually there's only 2 plus a transaction value. And the difference here is a smart contract is taking data inputs to run its function. However, on Ethereum-based chains, if you're sending value along with that transaction, so for instance, I'm purchasing an NFT, I'm sending someone money, or in this case, I'm buying some shares, the value associated with that, the payment, is actually its own kind of baseline value. It's a transaction value associated with the actual on-chain function call, right? It's not a parameter of the function per se. It's a parameter of the blockchain. Let's put it that way. So the 2 values, the 2 parameters actually in this case are these 2, which is the subject, or the in Friendtech terms, they refer to the subject as the room owner, like the person whose key you're purchasing. So here's the subject's address. Here's the amount that I'm looking to purchase, the amount of keys. And then buy shares is that transaction value that we're talking about. So the way this translates back to the function call is we have the name of the function here, which does have to be precise. If there's a capital, you need to include the capital. It's case sensitive. So we have buy shares. We have the user's own wallet, because again, remember, we're initializing the wallet, or rather, we're initializing the user's room for the first time. So we're having that user buy their own wallet. The amount is going to be 1. That's pretty much hard-coded. You don't need more than 1 to get access to someone's room. And then secondly, there it is. This is the transaction value. So again, the way the Friendtech contract set up, the first initializing purchase, which is the user buying their own key, is free. It's, apart from gas fees, but price-wise, it's free. And so this is where we put, what you don't want to do is put that 0 somewhere here. And trust me, I still make this mistake sometimes. And what would happen is it'll throw an error, which is pretty clear. It'll basically say something along the lines of, we were expecting 2 inputs, but we got 3, right? And then that should tell you right away, oops, I put a transaction value in as a parameter. The last thing is that transaction value should be more or less in the human readable units. So if you're talking ETH, that's like 1 ETH, zero point 0.1 ETH. If you're talking Matic, that's 1 Matic, 0.0 Matic, 0.01 Matic, or what have you. And that'll come into play when we actually get to actually people buying each other's keys, which we'll step through in a second. So here we're sending that transaction through. If it goes through, we'll see transaction sent successfully. And then same thing, we'll run through this custom workflow, which is to store our transaction in the database. And what we're doing here is we're creating a couple of objects that we are going to use in our app database. And my guess here is Friendtech's actual database in their app is going to have something akin to these objects. So let's take a look at this. So our data structure is pretty straightforward. We got users. We've talked about that. And we have a couple other things here now. We have a transaction. Let's start with that. A transaction is simply meant to document any purchases. So that including, we do want to track the purchase of the user's purchase of their own key. So we'll record a key transaction for that. We do want to have a concept of ownership, right? So ownership is a way of tracking relationships between the buyer and the subject. And parameter-wise, it's pretty simple. We have the buyer user, the subject user, and then an amount. So if we ever want to look up, hey, how many keys does this person hold of that room? There may be more than one. We'll do a search for this ownership. We'll put in the 2 user wallets or 2 user values, and we'll return the amount. Finally, what I'm calling a gallery is what Friendtech calls a room. That is a function of the owner of the room, but it has some important data within it. The 2 most important is the list of key holders, right? Who has access to this room. And second, which we'll get into for the chat side of things, a list of messages, which is effectively a list of these objects here, messages. And we'll step into this when we get to the chat side of things. On the user side, I do want to draw attention to some of the custom parameters here. So typically what we'll want to do is this is a little bit of the blocking and tackling. We'll want to store the user's balance. Yes, we're getting some of these from on-chain, but you also want to store them locally just because you don't want to always have to be pinging the chain for every little thing. You'd rather store something on the app database and then sync it or refresh it maybe once every page load or once when they log in, things like that. We talked about first login, buy price. We're going to store that as well, and we'll see that function call in a little bit. User gallery, there should only be 1 gallery, 1 room per user. So that's just a straight pointer to this object, that user's respective gallery. And just some tracking things. When was the last time they logged in? When was the last time they posted? And some lists, which are going to be helpful for us when we're doing different sorts of filters or lists of transactions, much like Friendtech does. When you log in, you can click different tabs on top, see different mixes and filtering methods of all the different transactions happening on the platform. And that's pretty much it. And we'll have a sell price too, but our particular app isn't going to be so focused on selling. So let's go back to the workflow. We have the create new ownership, right? If it doesn't already exist, we want to create a record that, hey, now the owner and the subject, the owner owns a key of their own wallet address. The second thing we want to do is punch in the key amount, right? And just a really small thing. The reason why we're separating this into 2 steps is just in case, for whatever reason, maybe we have a record of that user already. Maybe they were just doing some app-related things, and we deleted that user account, and they're logging again for the first time. This happens a lot during testing, and we don't want to necessarily recreate the ownership if it's already there. It's a good check just to make sure you're not, in coding terms, sometimes they would call that a memory leak. Like what you're doing is you're creating duplicates of things that are already there when you don't need to. So this is a good check to say, hey, I only want to create this once. I don't want to create like a bunch of these if we already have a record. And then because we're doing that check here, and it's conditional, this function call may not actually happen. We want to have a separate function to update the amount, which will always be run, right? So now we have a particular search. We're going to search for ownerships where the user is owning their own key, and that we're now pretty much guaranteed it will be there, because if it's not, it would have created it in the prior step. And then that's where we want to update the key amount. Similar type of concept here for key transaction. We only want to create a transaction if it hadn't existed prior. And because this is an initializing transaction, like we talked about, it's always going to happen for the user's first room, or the first time they're setting things up. It should exist. If it doesn't, we'll create it here. And the same thing, we'll add the list of transactions to that user if it's created. Now, the gallery, again, creating it if it doesn't exist. In particular, if that user doesn't already have a gallery, we will create it. And if they don't have a gallery, we will add that to their user account. And finally, this is, again, just filling out effectively the data for that user. We're going to add themselves to the list of keys they own. And that's pretty much it. After that, we forward the user over to the homepage. So we're going to do a quick refresh here. It should actually recognize that I'm already logged in and start to, there you go. And it recognized, it checked that I had a balance, logged me directly into my homepage. And here we are. So I'm going to move this button. I think because we refreshed, we actually didn't do the initializing purchase. So what we'll do here is we'll actually do that initializing purchase by our own key. We'll do a confirm. And this will be a good example of an on-chain purchase transaction. So there we did it. This is cool. So we purchased a key on-chain. We now have access to this gallery, and we can start to type things, right? So welcome to my gallery. There we go. Welcome to my gallery. Very cool. So we're going to step back out. What we should also see is that first initializing transaction now, and this is a list of transactions that we're displaying. And if we come back now to the gallery page, we'll see a couple things. We'll see the chat functionality, right? And the chat functionality is at the heart of it, a repeating group. It's a repeating group that shows one of two views. It shows a gray box on the right if it's the user themselves that posted that message, and it's showing a blue box on the left if that message is coming from someone other than the user that's logged in. So a pretty typical paradigm these days with text messaging and things like that. But that's it, right? And with each of these, you can do certain things like add replies. We do have the ability to add images. So let's go back to our gallery here. I'm going to add a random image. Let's say the old chat bubble. Send it along. And there we go. We got an image. And because this is my room, this is something that I added. So again, this is an example of Friendtech Plus. I've taken the original framework and I can now experiment a little bit. Think about what else would be cool. So I'm going to pin that to the page. And now anybody who comes into my room can see art that or images that I've pinned to the page. And for me, what would be a really cool natural extension of this is to make those mintable NFTs. And it's like an art gallery. They can come in, they can see art that I've minted, and if they'd like to, like in an art gallery, you look at the little white box next to the portrait, or you look behind the picture frame or whatnot, and there's always a little price that you could purchase that for. All right, cool. So couple things on this page. The chat function, we talked about how the messages are laid out. We will look at the, one second here, we will look at the send button, right? Or the send input, which is here. Again, Bubble ready-made with some formatting, of course, but a ready-made input here. This is a multi-line input, and then a button with an icon on it to send it through. I did put in a little bit of an animation. You might have caught it, which is a loading spinner and that's straight from Friendtech. That's how they do theirs. I thought that's a nice touch. So when the message is saving or sending, it is, hey, I have a little loader, and when it's done, it finishes. So all those are pretty cool. I'm not going to step through those per se, but needless to say, you're able to recreate that chat experience. And on top of that, you're able to recreate it in a fully responsive way. So if I were to shrink this page down into the size of an iPhone SE, still looks good. Still looks good, right? I can I can back out, I can scroll, all the good things. So coming back to the app, what's the other critical piece here? The other critical piece is purchasing a key. So we have a couple pop-ups, and what we might do is we might have one of my users purchase the key of this new guy. Let's see, globally, there's stuff happening. Node block, there's a new guy here. I'm going to go check out his room. I do not have access to this room, so I am going to buy a key. And that's going to happen on chain. Give it a couple of seconds, and it should come back. And we'll step through this. But again, at the core of this are those same write functions, write to smart contract. And then it'll come back with a response. And then we actually do a bit of a refresh. But that same mechanic is leveraged here. What we're also going to do is take a look at some of the privacy controls, right? So we obviously don't want to show any of the chat contents unless the user is a holder of the key, and secondly, we don't want those messages to be visible, even if the user's a little more adept at stuff and can inspect the source code and things like that. So I actually just refreshed a little bit because I realized my user wasn't still logged in. So I relogged in, and now we'll see what should happen is it should go through. And there we go. Yeah, it went through. So cool. Now I do own a key for this other room. And there you go. I can see his pinned image. I can see his initial welcomes. And here you'll see some of the additional chat functionality we put in, which is the ability to respond to a message or reply. I like your art. And that comes up with the quoted reply. And these are all actually just mainly UX things, formatting things. And I think, again, looking at Friendtech, it's really clear how they set things up. And to replicate that in turn in Bubble is not that difficult at the end of the day. So coming back to the other users' gallery, we're able to see that response in real time. Page is loaded, and automatically goes to the latest message. So all of these things, again, totally doable in Bubble, totally no code. And the one thing we'll step through in a little bit more specifics is that purchase function, right? So let's just jump right to it. So it's the confirmation click. So we're going to go to that pop-up. We're going to go edit that workflow. And here it is. Here's the root. That same ABI, same market contract address. We now are calling buy shares, but for not the current user's wallet, but the current page's user's wallet. So meaning we're in the gallery page. In Bubble, you can set up specific pages to have a particular kind of content that they expect, a particular thing. In this case, the gallery expects a user, which lets us do things like go to a gallery and
right now we're looking at the slug of the user, and the slug is their unique ID, but we could just as well make their slug their wallet address, which is actually, again, what Friendtech does for their rooms. And we just punch in, private gallery slash user wallet, and it'll go directly to that room. Now, we may not be able to see things because we haven't bought that key, but we could still, regardless, go to any room with a simple URL. And that's what this mechanism allows us to do, right? Setting up a page with the type of content and then going from there. So coming back to the workflow, we're going to buy this share. We're going to call this same function that we did to buy our own share, but now, again, we're pointing at a different wallet. We're still going to buy one. As far as I can tell, in Friendtech, they don't quite have the input yet to buy like bulk keys. It may be hidden somewhere, but I didn't personally see it. Just as well, you could have an integer input in the pop-up and fill it in and then put that as a variable here, but we're just going to keep things simple. Now, the user buy price, this is actually pretty key. So when the user first logs in and their wallet address is not empty, let's say, and their page has been loaded, we call a custom workflow that I've set up called refresh gallery, and it does a couple things. It checks the ownership, which is, again, same function call as prior, shares balance. In this case, the order of these parameters does matter, and through experimentation, I figured out that you can also do this by looking at the contract code, but also trial and error. So it is the subject and buyer, subject wallet, then buyer wallet. You put those in those order. The order does matter because, again, at the contract level, it has a very specific set of things it's looking for in a specific order that it's looking for. So here we're looking for shares balance. I'm using this little state, refreshing ownership, to just funnel the workflow the direction I want. So typically when you have a read contract action, it'll just simply respond back with contract read. But I wanted that response to trigger different things. So in this case, I want two conditions. I want the contract to be read, and I want the gallery's refreshing ownership state to be yes. That'll take me down this path. And here I'm going to update the key amount. We talked about that earlier. I may do certain things like add that user to the list of keys if they're a new owner, new buyer, or remove them. And this is more down the road if you had selling, but remove them if all of a sudden actually they sold their key. They shouldn't have access to that room anymore. And I'm going to refresh some other things, like this is a new one, get buy price after fee. And so what this function expects is the wallet that you're looking for. It's a price check, like how much is the next key, the cost of the next key if I were to purchase one. User's wallet, the amount that I'm looking to purchase. And buy price after fee, if we look at the contract, right, there are two buy price functions. And again, this took a little bit, it should be a read. There's two buy price functions as well as two sell price functions. There is the concept of a protocol fee or a transaction fee. It's set at 5%, I believe, normally. And what it is doing is giving you the price. So for the buyer, that fee is actually added on top of the price, right? So it's a two-sided fee. The seller gets that deducted from their proceeds. The buyer has that added to their, cost, right? And so this one actually, again, trial and error. You can get the plain price, but actually what the contract is expecting is this one, right? If you go to buy, if you trigger that buy shares function and you give it this price without the fee, it's going to throw a rejection back, an error back, and say, this isn't the right price. So you want to get the buy price after fee. And so that's what we're going to do here. We are going to then wait for the response back again. And again, this is a read function, but what I've done here is I've toggled this yes/no parameter now to refreshing buy price. I've cleared the refreshing ownership one, so that's empty. I've set the refreshing buy price one to yes. So next time it comes back, it's going to look for that yes value. Now go down this set of actions. And a couple things here. We have another plugin that is part of the Web3 and MetaMask plugin, which is called Web3 Utilities. What it does is it just translates numbers back from way to not. For those who aren't familiar, just simplest terms, there's the currency of Ethereum-based blockchains typically goes out to 18 decimals. So whereas dollars go out to 2 decimals, ETH goes out to 18 decimals. And more often than not, you're actually using those decimals for things like paying for gas because it happens on a very granular level. And so a lot of contracts will actually respond and give you those transaction values in like the base unit, which is called Wei, which is in dollar terms, that would be the penny, right? In ETH terms, that is 18 decimals removed. Like one Wei is like 0.0000000, 18 zeros and actually technically 17 zeros and a one, right? And so obviously we don't want to be messing around with 18 zeros all the time. So we have these simple functions here, which takes something that is in Wei, i.e. the penny of Ethereum or Matic, and we want to translate that back into a value in the human readable terms, right? In ETH or Matic. Okay, and so that's what we're doing here, because when we store it, we want that value to be, again, more readily used for things like displaying price on the page. So if we went back to the page here, that's what we would show up here. And as you can see, this is 0.001 because it's in Matic. If it were in Wei, it would be, what is that? One with like 15 zeros after it or something, like 1 quadrillion or something like that. And obviously that's not going to be super helpful for someone who's looking to just buy a key. So the last thing we're going to do is we're going to then that's it, actually. So if we had a sell price, we'd also do a similar step here, which is refresh, but using sell price. And we'd record that as well. But like I said, for this current app, it's mainly focused on buy price. But that's how the refresh works. And finally, if we go back to the actual purchase function, are you sure? There we go. So we have the right contract. Now we have buy shares, and we double clicked into this, right? User buy price. So that's how user buy price is set. Now we're going to have transaction sent successfully, and that's over here. And there we go. Similar step to what we had in the initial, the initial setup for the user themselves. We want to do the same things. We want to record a new transaction. We want to relate that to the things that it should be related to, like to a particular user. Add that to their list of transactions, for example. We want to, now that they're a key holder, we want to add them to the list of key holders. We want to update, let's say, actually, you know what? I think something might be missing here now that I'm looking at this. We want to update the ownership. User list of transactions, make changes to current user. We'll look at this in a second. Yeah, actually, I'm missing the ownership, so let's add that. So we want to make a change to a thing, which is going to be search for ownership, where the subject is going to be the current page's user. The owner is going to be the current user. And we don't necessarily need to sort. We want to update the first thing that gets returned, and we want to update the amount to be transaction amount, right? We want it to be at least 1. There's a chance here that it could be more than 1, but we can rely on the refresh to do that, or we can embed another shares balance function in here. So again, you can start to see how you start to daisy chain some of these things together to get different behaviors. This is a little bit of a shortcut here because this could be their 5th key that they're buying, and let's actually put something as a precaution in here. Let's put we'll only do this if the ownership amount is 0 or empty. Let's do that, right? So key amount is 0, because what we don't want is what we don't want is for them to have 5 keys and all of a sudden, you know, it says they have 1 key, right? So that's not good. So let's go through this again. Subject equals current page's user. Owner equals current user. First item and is empty. So the reason why we want to put both here is because, again, in some ways, Bubble is still a coding language and it can be quite precise, which I think it should be. Meaning, if you only had ownership first item key amount is 0, and it turns out that this is the first time that ownership was created or it's been referenced, and that value is actually empty, this would not return true, right? So it would actually say, oh, it's empty, but that's not 0, so this must be okay, which is not what we want, right? We only want this to be called, well, we want this to be called, this action to be called when it's empty as well. And that's why we need to explicitly say both. We want to say when it's 0 or when it's empty, and that'll, make sure it's called both times. And the last thing we'll do here is we're going to make these guys friends. So in Friendtech, this one is actually not explicit, but I've kind of inferred what it means, because I personally have not purchased anybody else's keys. I think Friendtech is cool, but I'm not looking to invest in it per se. The thing that I've inferred is that, and I think logically it kind of makes sense, is a friend is established when you have the relationship going both ways, meaning both users hold each other's keys, right? So what we're going to do, so we see here, oh, they bought my key, so maybe I should buy theirs, right? So I'm going to do that. Oh, okay, and I see that they hold my key, so let's return the favor. And you can see the price is higher, right? 0.001 as opposed to 0, because there's already some holders. And there we go. Now we're a key holder. We can see their messages from prior. We're gonna step back. This value still is not updating. I'm actually curious about that, but I think we can take a look at that real quickly. But the transaction definitely did go through, and what we should see now is, there we go, friends, right? So we now see all of the transactions either related to ourselves or to this user who we're now our friend with, and we can kind of go back in the history of how, when they were initialized and things like that, which is kind of cool. So I think in terms of functional walkthroughs, that covers the bases. I'm going to step back to this real quick and kind of close things out. So what did we go through today? Number one, we went through why Friendtech is unique, why they have had, in my opinion, the success they've had, because they've made a lot of smart decisions, some bigger, some smaller, but altogether, more often than not, they just really stayed focused on who their users are, where they're coming from, and just keeping it really focused on what they want to do, which is chat, transactions, and keys, right? And second thing we talked about is breaking down all of those features in terms of what they actually translate into, in terms of, like, if you're going to build that, like, what does it take to have that feature in your app? And so we've walked through that. We've walked through the smart contract, PWA, Twitter or X authentication, account abstraction with a non-custodial wallet, and also the actual buying and selling of keys, or said another way, the interaction with smart contracts on chain. And we've talked about how the beauty of this is, now that you understand and can actually implement these types of features, why stop there? You can add your own take on things. You can add additional features, your own creativity, and really not not literally come up with the second Friendtech, but let's say build something that's inspired by Friendtech and takes it even further. And last thing we'll do is do a quick step through of the recipe, the recipe for each of these. So smart contracts, a combination of the chain explorer, in this case was Basescan. For other chains, you'll have the relevant chain explorer in that case, and you want to inspect the code, assuming the code's been verified and is visible, which thankfully Friendtech did verify and it's open. We then use Remix to compile and deploy that. For PWA, you can do this as a homebrew, but I would actually recommend Progressier. It is a paid service, but I think if you're really focused, like laser focused on mobile, then I think it's a worthwhile investment. And Twitter authentication or X authentication, we went through that. It's a bubble built-in feature, which actually works really well. Um, that combined with Web3 Auth as the wallet connection utility is a really good combination, really powerful combination. And basically, I'm trying to think if we're missing anything on the Friendtech experience, but no, I mean, basically, you in that case have recreated, if not more, what Friendtech has because you can actually add Facebook logins, Twitch, Twitter, Discord, WeChat, all these different logins. The And finally, interactions with smart contracts on chain. I think in this particular case, this clone was kind of fun to work with because it's so distilled down. There's not a whole lot going on, including the actual core function calls. So once you get that smart contract right in the first step, it's really kind of fun to like interact with it, right? Because it's so like boiled down, the contract itself, it's super responsive. It responds really quickly. Things are transacted generally really quickly, and it's kind of fun, you know. And the fact that you can now do this on your own, completely in no code, and maybe not in 24 hours if this is your first shot at things, but certainly much faster than if you were doing this with a normal stack of code and GitHub and things like that. So anyway, I hope everybody has found this helpful. I had a lot of fun doing this, even though it was a pretty late night. I was trying to get this in for a hackathon for Bubble with my time here in Honolulu, a 2 a.m. deadline. I think I literally pressed the button to submit at like 1:58 a.m. So it was kind of a late night, but all things considered, super worthwhile experience. I learned a lot. Again, much respect for Friendtech, the entire team, for what they built, and really pushing the whole Web3 community and the Web3 mission further, right? By bringing Web3 much closer to the average user and making it more fun and just usable, right? Cool. So I hope that's been helpful. This will wrap up episode 6, and I look forward to seeing you on future episodes. Take care.